A projectile is any object or particle that is acted upon by the force of gravity. Projectile objects may be dropped, thrown, launched, or rolled into space. Once projected, these objects will continue in motion due to their own inertia and gravity's downward pull. To better understand the nature of projectile motion, consider a ball rolling off a table. Notice that as the ball leaves the table and falls through the air, its path follows a downward arc. Let's chart the ball's vertical and horizontal motion for every tenth of a second of fall, where the x-axis is changed in the horizontal motion and the y-axis is changed in the vertical motion. Notice that the ball's horizontal movement is equidistant for every unit of time. This is because there is no force accelerating the ball away from the table. The only force acting on the ball is gravity, accelerating the ball towards the ground. The curvature of the ball's trajectory is the combination of its constant horizontal motion and its increasing vertical motion. Mathematically speaking, the outline of this path is known as a parabola. Imagine now that a person launches a ball off of a cliff. We know that if the force of gravity is not present, the ball would continue to travel in a straight line away from the person. However, because of gravity, it causes the ball to fall toward Earth as it flies. After 1 second, the ball will have fallen 5 meters from the imagined line of gravity, less travel. No matter how fast the person throws the ball, this fallen distance of 5 meters after 1 second of air time will remain the same. However, because the Earth is curved, dropping 5 meters for every 8,000 meters tangent to its surface, there is the potential to launch a projectile so fast and far that it falls around the Earth rather than into it. These objects are known as satellites. A satellite is any object that orbits the Earth, falling continually due to the planet's gravitational pull, but traveling fast enough so its trajectory will follow the curvature of the Earth, thus never hitting the ground. However, in the example of a ball being thrown, the exact speed at which the baseball would need to travel to avoid colliding with the ground after its first 5-meter drop would be 8 kilometers per second, or 18,000 miles per hour. This is hypothetical, of course, because that speed is much too fast for a person to throw, and traveling that fast within the Earth's atmosphere would turn the baseball into cinders. But this is not the case for rockets carrying missiles that launch satellites hundreds of thousands of feet into the atmosphere to begin their orbit where there is little air resistance to inhibit the satellite's fall.